of the objects vibrating was caused actually by self-resonation of what they call ferromagnetic and piezo electric and ferromagnetic barium titanate. And this was used in the Army for levitation experiments. And this particular experiment here is showing a crude form of levitation that causes heavy objects with 7 pounds here to move around on a piece of aluminum plate through self-resonance, which is many bands and frequencies that I was causing. And other objects tend to move around, but only on translational movements. Basically, I'm doing a self-resonation system and adding on to it different carriers through the top amplifier and tuning in, broadening the frequencies, the pulse rate, and that causing it to react in different shapes. It's almost controllable translational movements. There's really no difference on the surrounding materials from the main cylinder. It can be plastic, steel, or very heavy objects will tend to slide around a bit. And yet, if you suspend a ring above the barium cylinder, you notice that the ring is held by some type of invisible force. So the applications of this in advanced applications using free energy or zero-point energy to power it would be in propulsion technologies. And that would be applicable to the forces that this type of material puts out. The objects you're seeing moving there is a form of levitation by translational movement, meaning that the objects become lighter and can float around. The heaviest being the barium cylinder that you see there with the 2 wires coming out of it. Tends to slide around on 7 pounds of its own weight. So that's basically what you're seeing. The physics of it is self-resonation through a power amplifier and broad and narrow bands of electrical energy going into this crystal. The long-term applications could be used in space propulsion and perhaps in medical research and metallurgical research. Well, microphones actually are made out of the same material as the large cylinder of barium titanate, and there's a self-resonation effect taking place there. And that goes through the amplifiers, and then I broaden and narrow the bandwidths and add pulses in that to create the effects you just seen. Using common minerals, I'm able to capture the jitter of the zero-point energy that's a hot talk of many physicists around the world. And I'm able to create cells and structures similar to this one here that actually produce power for long periods of time. As you can see, we're getting a reading here of almost half an electron volt from this pile of crystals. And this is steady and has been tested up to a year's time and under stress tests also. So, which made me decide to then, of course, mount the same material in cylinders. And these cylinders here, of course, are various types of cylinders. One being an artillery shell or aluminum cylinders. I could take this one here and do a reading on him. And actually you cannot see that, but we'll try here. I can't tell what we're getting. About half a volt, about half electron volt on this guy here. Different cylinders, of course, there are different mixes in there, and I found that that some of the cylinders are not as powerful as this material here, or this very tiny one here. Actually, this has more power than this large artillery shell unit here. And what I want to do, of course, is to demonstrate it in the sense of it making actual power. That means to turn a small motor. And that can be done. I've accomplished that many times. We're just taking a reading here on the very small one, 1 cubic inch of raw material from the earth. It's still powering for over a year. Basically, I want to use these as replacements for batteries, which I think I can achieve. And to demonstrate even more so, I'm looking for a hot cylinder, which I'll call a hot one. Well, maybe this one, which is a combination of material from this little cylinder back into here. Instead, actually, well, we can take a voltometer reading on him and see if he's up to par. We get 1.635 electron volts, so I think that he's lively enough to power this little motor. We'll find out. So I'm holding this motor here. I attach a lead to the base. Get him out of the way. Okay, I'm attaching this to the base here. Another lead to the top, and it should spin, which it does. So yeah, basically, this kind of material powering motors. Of course, it's a very small motor at this time, but scaled up in larger amounts of material can power up to several horsepower if needed. So that basically is sort of the secret to the energy crisis, in my opinion anyhow. It's using ordinary materials, non-toxic, that will interface with zero-point energy in space and time. Now we're taking a reading of one of the most powerful ones, the 1.635 volts, fluctuating a bit, but very steady and strong. And that was the one that powered the little motor. There's quite a host of natural, non-toxic minerals in there that activate. Much similar to the Moray valve of 1927, where Moray used natural minerals and got a lot of power in the range of about 5,000 watts, usable power at 110 volts at 400 cycles per second. Long wire antenna. Using basically the same kind of principles. It's sort of a shake and bake recipe. It's extremely simple, ridiculously simple. And I do that. I simply just put it in, heat it up, shake it around, and let it crystallize. And once it's crystallized, then it captures and conforms to the zero-point energy that's around all of us. And actually I find the most simplest of recipes the most powerful, meaning this little fellow here, where I tried to advance the field strength or the energy, however failing in a few of these cylinders, which are quite, as one would say, it would only put out millivolts. This one here is another powerhouse unit. Being smaller, actually, they tend to get stronger. Again, it's reading about similar to this pile here. But again, I should take a reading on this because he's quite interesting to a lot of people. Being the smallest of them, that would be approximately 1/3 of a volt. Always steady, always strong. I've used direct shorts on these connecting together for days at a time, and they still keep on pumping out energy. Some explanations, of course, can be found in solid-state physics in the old ham radio magazines when transistors were first coming out. And that will help the viewer to see some of the technology in those days, and for the future can see also the possibilities of what they call a space charge and junction barrier type of technologies in crystals. The interesting aspect of this technology is that these cells, crystalline cells, can be put in series and parallel to add up voltage and also add up amperage. So theoretically, if you had a room or a refrigerator full of them, you could power a lot of different types of appliances. You can have 110 volts if you wish, if you had them all in series and in parallel for the amps. Plus, well, also they cooperate with one another, going in series and parallel. This makes them quite practical. Plus, they're very cheap to make, and they are basically from just nature's own raw minerals.